Let's go ahead and get started. Welcome. Today we're actually going to go over a lot of material, but of course there's the hurricane news, so if that does blow through, I guess I'll send you all emails to keep you updated on what to be working on. Today I'll be eventually doing our first project, so you will have plenty of work to be doing if you're in the dark and you don't even have electricity to go on a computer. You'll still have plenty of work to think about what you should do on your project. So don't worry about that. I got you covered there, all right? Got your back. Not a problem. Not a problem, anytime.
You know what we wanted.
Oh, yeah. Okay, today, if it goes as planned, there's going to be a lot of little things we're going to cover today that should basically tidy up everything we've learned so far and get us prepared and ready to actually start studying data structures, actually start getting to something. So today, again, I'm going to go over pointers a third time with the slides. Hopefully this will be very straightforward this time, but tons of students constantly have issues with pointers, and I understand that. They're very tricky at first and a little confusing about what they do. So I'm going to go over pointers a third time. I'm going to do a quick recap on classes, and then we'll talk about your lab, next lab, which is basically the array lab with classes. How many of y'all have started on the, or just standard array lab? Are you still doing the whole GNU plot and performance-based lab? You started on the array? Oh, you're all doing performance, or?
Well, I've been having some issues with mine, but I'll talk to you during my time, I guess.
Okay.
It's not finding the package for some reason.
Oh, okay, so package issues. All right, yeah, I'll help you with that. All right. Well, hopefully you get to the array ones. Are any of you all afraid of the array lab? Hopefully it looks straightforward. Good. So we'll start moving on to classes. In this class, I do need to at least cover virtual functions. We're going to cover it, do one lab, and then never touch it again. Basically, the whole reason for it is so you understand how C++ does in interfaces, the essential interfaces in Java. It's actually a lot more complicated, in my opinion. I think Java cleaned it up a lot, but we need to go over that as well as abstract classes. And then we'll talk about lists, which, by the way, is what an array is. Hopefully that'll tidy everything up. I do need to go through basically a little makefile explanation, because the makefile lab was already due, so now I can go in and show you how real makefiles are written. And then we'll go talk about your project. So, a lot of little things. Let's go ahead and get started with pointers. All right, look, he says objectives. By the way, these are the slides from the book. We'll start, get through all that. We're going to start using these slides to at least talk about the different data structures. Before I've been using my own slides, now we're using the book. So this should follow the book that y'all have. This is chapter 12, this is where I'm starting. Do you recall what chapter y'all finished up with in procedural? No. There's probably a gap between where you ended in procedural. You probably stopped at 8 or 9, and then this is 12. That gap is really what Java covered, OOP. Of course, it's the C++ version, so conceptually speaking, you shouldn't have lost any material, but if there is something that is confusing, you can review those chapters. All right, so what's a pointer? What does a pointer contain?
Memory address.
A memory address. All right. No name associated with pointer data type in C++. Oh, the plus is on the next line. So syntax, if you are to declare a variable. So this is the syntax to declare. Keep in mind, this is declaring, not actual using. Using it is slightly different syntax. Declaring it is its own syntax. So you have your data type space star identifier. Please, please, please use this type of syntax. Otherwise, you're going to get yourself into trouble. Here's some good examples: an integer pointer P, a character pointer CH, and then these three statements are actually equivalent. Okay. Notice that if the star is next to the P or the star is next to the integer, it's the same thing. Why do you think I want you to use the first version and not the second?
Because it's on the variable.
It's on the variable.
Just make more sense.
It makes more sense.
Instead of it being like on the int.
Right, okay.
In between.
So here we go. Let me go ahead and, where are we? We're doing pointers. Okay, good, pointers. Oh, we got plenty of pointers examples, good. We'll do a pointer declaration.cpp, beautiful. So let me show you what's going on. Welcome.
Morning.
All right, so if I do int star p, and then I have int a equals 32, I have or I should say p is equal to the address of a, and then I can do, see out the dereference of p equals, which should give me what? 32. All right, let's open tab, g++, pointer declaration, -o, pointer declaration. Good. And let's go ahead and run it. Whoops. All right, 32. Beautiful. All right, this is why. All right, if I put it over here, it's going to do the same thing. Okay? Oh, see? This is why things get confusing. What if I were to do this? What is b?
It's another pointer, right?
It's, someone said it correctly.
Just an integer?
It's just an integer. That's confusing because you think you're declaring the type over here. But if you do it this way, it's actually clear that p is a pointer to an integer and b is not. All right? This is why always when you're declaring, please put the star next to the variable, otherwise you are going to get confused very quickly. So I can do b equals 16, and then I'll go ahead and print out b. Right, so b is 16. All right, different ways to declare it. Here's another example. If you do it in this statement, p is a pointer variable, q is an int. So please always, to avoid confusion, attach the character star to the variable name when you declare. All right, good. Address of, if you put the ampersand in front of a variable, it will generate the address of that variable. So p equals the address of x, so p is storing the memory location of where x resides. If you did the ampersand in front of p, what would that tell you?
I think if you had ampersand p equals ampersand x.
So in this example, if I decide to print out, see out ampersand p, what is that going to display? Well, it's the address of operator, so it's going to tell me the address of
X. Right. So originally x.
no.
No.
It would be the address of, yeah, come on, yeah, just correct. Just read it literally. So if you put ampersand p, it's going to give you the address where p resides. P happens to also hold at that address the address of x. Okay? Important to keep that straight, especially in your project. All right, dereferencing. Once you have declared the variable, if you wish to dereference it, then you put the star in front of it. Notice that the declaration and the usage have two different meanings with the star. So afterwards, if you wish to dereference it, you put the star in front of the variable. We did this just in our example. Notice up here we declared it with p. Over here we set what's being stored in that pointer, namely the address of a here. And then if I want to jump to that address and print it out, I did star p to jump to that address or to dereference. Naturally, you can declare pointers to other data types. What can you declare a pointer to?
Anything.
Anything. All right. Everyone got that? You can point to anything. So, of course, you could declare a pointer to a struct. It behaves basically the same way. Now, student pointer is going to store a memory location of where a student object resides. At least, hopefully, it does. And then you just use it the same way where you ampersand the student in order to get the actual memory address of student. Now with the pointer, how do you get to the GPA? Notice it dereferences the student pointer and then does .gpa. You have to use the parentheses because the dot operator has higher precedence than the dereferencing operator. What does that mean?
So it's called GPA before it would.
Right, if we didn't have the parentheses, it would try and go to the GPA of the student pointer and then dereference it, which would only end poorly. So you need to put your parentheses around that star if you wish to use the syntax up here. Creators of C++ knew that that was annoying, so they created the arrow operator, so you can just do arrow instead of star student pointer. Everyone good with this, or do you want an example? You good, Jonah? All right. So yeah, you can do student pointer variable, arrow member, right. So aka this line up here just becomes the arrow GPA. We're good to go. C++ does not automatically initialize variables. In fact, it doesn't automatically initialize anything. Why did they choose not to initialize things?
Customization.
Customization? Let's see. I guess to a certain extent that's true. But there's a bigger reason for it.
So you're not holding unnecessary spots in memory.
So you're not holding, I'm sorry, say again?
And so you're not holding unnecessary spots in memory if you're not using it or initialize it or something.
Okay. Well, I see what you're saying. But in this example, if you have a pointer, they're not going to initialize the pointer to null so that you know that it's empty, right? They're just going to be whatever it happens to be. Why would they not initialize the pointer to null? Because you want it, in general, you want your pointers to be initialized to 0 so that you know that it currently doesn't point to anything until you actually create it on the heap. Why wouldn't they want to automatically initialize pointers? Java, by the way, automatically initializes your pointers to null and automatically initializes your integers to 0. C++ does not. Why would they do that?
You got me there.
Got you there?
Yeah.
Performance. It costs time to initialize a variable. Although incredibly minute by today's standard, it does cost time, and that's why they chose not to do it. For most applications, that is absurd, because if you're doing a web app, if it takes another nanosecond, who's going to notice? But the thing about C and C++ is it's usually used for system development, and that nanosecond may be used, a million times, in which case it does actually add up to something. So you have to keep in mind that this language was made for system level development, so very low level operations, which means they need to keep performance in mind when they're designing the language. All right, so you need to initialize pointers to null. In other words, over here in this code, bad practice, we should actually have something like this. And of course, we'll need to include stdlib.h. That way we know that p is null. By the way, null is 0. All right, dynamic variables. Right, so this is new and delete. All right, the book calls them dynamic variables. It's when you want to allocate something on the heap. New and delete are reserved words in C++. All right, we've gone through an example of this, so we should be good with new and delete. Yep, new, to allocate a single variable or an array of variables. The allocated memory is uninitialized. Why is it uninitialized? Performance, yes. Just one of those techniques, just make sure we keep that in mind. So we can do p equals new int, creates a single integer out of memory, and then you can access it by doing star p. Great. Dynamic cannot be directly accessed. Ooh, why is that? Well, maybe not why is that. C++ does not allow you to directly access it. In order to access something on the heap, you must do it through a pointer. Trying to think of how that would even make sense to have it directly accessed with variable. In C++, that doesn't make sense. So if something's allocated on the heap, you must use a pointer to get to it. All right, we talked a little bit about memory leaks with Valgrind. Make sure you delete everything with new, and you can use Valgrind to detect if you have any memory problems. After you delete it, the pointer is not updated. They don't change the pointer and set it to null. Why don't they set it to null? All right. 3 times I've asked it. Now we're doing great. So after it's deleted, make sure you set it to null. For this class, it's good programming practice, because if you don't and you try and use the variable later, bad things are going to happen. Or I should say, your program will have undefined behavior, which means you don't know what's going on. All right, what do we got? Delete only marks it. If you try to access it, yeah, avoid by setting pointers to null. Just said that. Ooh, pointer arithmetic. Okay. I need to do another lab on pointer arithmetic, because we can go very long on this. Programs can accidentally access memory locations of the variables without changing their content without warning. So we have to exercise care with pointer arithmetic. Let's see if they actually show you what that looks like. Great. Perfect. So what is this doing right here? P++.
Incrementing B.
Incrementing P, but P is an integer pointer, so how much does it increment it by?
An element?
1 element. So if the variable was pointing, let's just say the pointer was 100. Obviously, it's probably not going to be. But if it's 100, you do P++, what's the new value? It's not 101. But you said it's going to the next location, right? So how? 104, right. Why does that have to be 104? Because it's what?
4 bytes.
Yeah, it's 4 bytes. Perfect. So when you do P++, it's going by 4 bytes because the integer is 4 bytes. So in order to go to the next integer, it has to increment by 4. What if it was double P? What would P++ be? How much would that increment by?
8.
8. You got it. So then you increment by a plus, aka +1 is actually incrementing by 8. If you had a class, what would P++ be? Trick question. Well, if you have P was 100 and you had this was class, your own custom class, how much would P++ increment by? If an integer was 4, a double was 8, then it would be 60. 4. So maybe. It increments by the size of your class. So if your class size, the data size of your class was 16, it would increment by 16. If the size was 4, it increment by 4. If you had an empty class, it increment by 0. I don't know why you'd be having a class with no bytes in it, but you know you can do that. It's Java, it's C++, we can do whatever we want. Though you can't do negative, although I might be able to figure out, oh yeah, you can, because you override plus in order to increment by a negative amount.
So, it says P++ points to the next array component.
To the next, if P++ will point, yeah, next array component or the next array element.
So, start P equals 25.
What's that set?
That's setting the memory location to 25. I mean, setting P to point to 25.
No, because notice the star in front of the P. It's dereferencing P, so it's going to P. Wherever that memory location is, it's stuffing 25 there. Where is P currently pointed to? Element 0. So it's going to store 25 in the first element, aka element 0, the first part of the array P. Because it's dereferencing P, which is pointing to the beginning of the array, and then putting 25 there. Then it increments P. So then where is 35 going to? Not element? Element.
1.
So, hold on. We're getting our off by ones here. It's the second element of the array, or sub 1, so to speak. Does that make sense? Is that coming, PJ? Or
I understand the memory look like the pointer part, but I guess part I don't understand is, normally you would have to say, like, if it was a normal variable, not a pointer, you would have to say, on the, A, and then you have to put the index, you know what I'm saying?
Correct.
So if you just start out, it's just pointing at the first index.
Right. So this pointer is just pointing to the beginning.
Okay.
Right. So dereferencing is going to access the first element. You increment the pointer. Now the pointer is pointing to the second element.
Yeah, okay.
Now what gets confusing here, all right, let's see what we do. What if afterwards I put P sub 5 equals 45? You know, solid brackets. What is that doing?
That's probably, I don't think that's gonna work because you don't have,
It will work.
even though you don't have items in spaces 2, 3, and 4.
Yeah, you don't. Yeah, it doesn't matter. Yeah, it doesn't have to be incremental. We don't. This is C++. It doesn't matter. Doesn't matter. What would it be doing? Notice that the array. How many elements does the array have? 10. So after this line, after the store is 35, I did P sub 5 equals 45. What is that doing?
Going to the sixth element in the array, changing it to 45.
You're close. 7th. Because you incremented P by 1, right?
Mhm.
So P sub 5 is 1 plus that 5, which is sub 6, aka the 7th element. Any questions on that?
But why wouldn't you have to dereference it first in your example you just came up with?
So let's go and do the code, because I can see that this is can be a little confusing, and that's perfectly fine, I understand. Let's see, pointer declaration.cpp to pointer array. That's CPP. All right. New int sub 10, perfect. So we do star p equals 35, we print it off. We do p plus plus. We'll say, actually it was 25, right? And then 35, and then we'll print it out. So what should this print out? It's going to print out two things. Yeah, 25, 35. All right. Make sure I do debugging in case we need it. Perfect. All right. Now, let's do p sub 0. What's p sub 0 here? So we have 25s, 35. Remember, p is pointing now to the second element of the array. So if you, sub 0 just means jump over 0 elements from where p is pointing. Well, since p is pointing to the second element of the array, it's going to print off 35. And you know, a syntax I've actually never tried in C++, and we're going to do an experiment. I wonder if this is legal. It should be legal because, you know, it's C++. Yep. Perfect. So p sub -1, bet you didn't think that would happen, is now 25. Why is that now 25? Because we're going backwards one element.
Sorry, can you do P minus minus as well?
Yes. So now if I do p minus minus, I print out p sub 0, what's it going to print out? Okay.
So when you increment or decrement like that, the pointer index of an array just shifts everything. So if you increment it,
It has not shifted anything. There's no shifting. The
it's
pointer
pointing
is
at the second one. and
Now
so
it's pointing.
now there's a negative index.
now index -1 is a legit memory location. I could at any point put -2. This is why C++ is tricky. And it would compile and run. The behavior would be undefined because I don't know what's actually at -2. That's not legit. But what you're trying to think is legitimately, yes, you've moved it so that -1 is something you can actually access. Morning, Blake. All right, so plus equals 4. Actually, let's do it this way. Let's put out what P equals, and then we'll plus it by 4. Let's see if it's going to do what I think it is. It did. Beautiful. If I add 4 to P, how much is that actually adding?
16?
16, yes. And that's what it did. If you're it, notice that the hex, this one over here incremented by 1, which is actually 16 in hex. Hexadecimal 0 to 16, so adding 1 to the next to the last digit in this one, because we're doing little endian, actually increments it by 16. Okay. Let me try and show that differently, because the pointer thing might, or the indexing might be a little confusing. So it did P sub 4 equals 100 plus 4, and then I run and compile. It's now 100. Notice over at 4, I put 100, I increment the pointer by 4, and now if I just go to 0, it's now 100. All right, another thing I want to show you. These are the same exact things. They are exactly the same. Okay? They do the exact same thing. Now if I do P sub 1 equals 200, something else I want to show you. Again, those two are the exact same thing. In actuality, the subscript, the solid brackets, is a shorthand for the second line. The second line is what the compiler actually looks at and generates code for. The first one is a shorthand for your convenience. All right. I'm not going to go into multiplication. I think addition is complicated enough, and you should never need multiplication. If you're doing multiplication and division, oh boy, you're doing something serious with memory, which does happen, but hopefully you don't need to do that for this class. Any questions about this? All right.
Is this used like commonly? It just seems very.
Yes.
It is.
The reason why it's used so much, you have to remember this is a designed for a system level application. When you're doing a device driver, you just have a pointer. And you just need to know, and the thing about device driver, the first 4 bytes might be an integer, then you might have a double later on, you might have a float, or you might have a record, all in this jumbledness. So you just have a pointer that jumps around to the right location so you can access it. Also, some people want to iterate through the memory or a device driver correctly as well. The point of this is because device drivers are very low level and you need to make sure you access it verbatim correctly. As a side comment, historically speaking, before I would say the year 2000, somewhere between the year 1995 and 2000, somewhere before that era, using the pointer and incrementing it was faster than using the subscript, because the compilers were not strong enough to identify them both in this thing. You know, now it's the 21st century. What I just told you is a moot point because all compilers can figure it out now. But still used for device drivers. Okay. All right, don't worry about that. All right, good, we have a function. We need to talk about rows. I'm going to stop the video here.